Well, good afternoon to everyone. I will try to present today this Wodel-Edu is a tool for the generation and evaluation of diagram-based exercises. Well, I think it's not sharing yet. Okay, now you can see it. Well, I've done this work with Esther Guerra and Juan de Lara. We are from the MISO group here in the Universidad Autónoma de Madrid in Spain. Well, which the motivation of this work is that there is a lack of frameworks to generate domain-independent exercises, and also there is a need to generate a high number of these kind of exercises due to these online academic courses and well, as you know, with the pandemic, many of the courses have become e-learning, and well, these kind of assistance tools can alleviate much of the professor's work. So, well, we propose this solution that is an extension of the Wodel tool that we have created for model mutation. And this proposed solution is, as I was saying, targets the generation and evaluation of diagram-based exercises for any domain. And we have called this tool the Wodel-Edu tool. And this is what we are going to show today. Well, the overview of the work, the process followed to generate and evaluate these exercises using Wodel-Edu is that first, well, there are three main roles in the process. The first, the language engineer takes the control. He or she must create the domain meta model. She also needs to define the concrete syntax, the graphical concrete syntax, how we are going to represent the models. And well, we have created a DSL for this purpose that is called model draw. After that, she must define the mutation operators, which operators are going to be used to generate the variations of the seed models, and to describe or to define these mutation operators, we have used the Wodel DSL. And after that, this language engineer must define a textual representation also for the model elements, that is this purpose of the model text DSL, and also for the mutation operators applied, that is the mutatext DSL. So we have this family of DSLs also with the EduTest DSL that enable the generation of these diagram-based exercises. After that, well, we are ready to deliver the tool to the professor, and she must input some seed models that can be either automated generated, or he can create them by hand. Okay, and after that, she must define or configure how the exercises are going to be created by using the 7 kinds of exercises provided, that are all of these, and several configuration options like the number of attempts that can be used to complete an exercise, or the order of the exercises, and so on. And after that, she can generate the platform to deliver these generated exercises to the student. Well, currently we have included code generators for Moodle, Android, iOS, and the web. And well, in the 8th and 9th steps, the student group can solve the exercises, and they receive an automated grading. Okay, so, well, we move on with the presentation. Well, these are the 8 main steps followed to complete the process, as we are saying. And now we are going to see the tool live. Okay, well, I have a video here, and I will try to describe it out loud now. Okay, so, well, the first thing we must do is to load or create the domain meta model in the process. First, we create the Wodel-Edu project. It's an Eclipse-based tool, as you are seeing. We name the project, and we also name the main mutator file, that is the Wodel-DSL, and we select the extension of the Wodel-Edu framework, and we load the domain meta model. And in this case is an example on logic circuits. We generate the resources for the Wodel-Edu project, and well, now the project has been created, and these are all the resources required to generate and evaluate the exercises. Now we need to complete the DSLs. First, we define the concrete syntax by using the model draw DSL. So we have commented a template that we can base our configuration. And in this case, we also have this code assistance, syntax completion, and well, you know, these features provided by the X-test framework. And well, and for example, the gates are going to be logic shapes, nodes of a logic shape, and well, we complete the specification. Next, we define the mutation operators using the Wodel DSL. We can define in different blocks the different mutation operators that we are going to use. For example, we are going to retype, that is, modify the type of an AND gate to an OR gate, and the other way around too. So, well, we need to declare it as blocks, okay, with this directive. And we also can input the number of mutants for each block, for each mutation operator. And after that, we define the textual representation of the model elements with the model text DSL. In this case, to describe a gate, we use the type of gate like a prefix, you know. So, well, this is the syntax used by this DSL. So a gate must be translated to its type and followed by the word gate in natural language. This is going to be used in the text options of the exercises. So, well, a gate, a starting gate of the circuit is going to be preceded by the word input, okay? And, well, we complete the specification. After that, we define how the mutation operators applied are going to be translated into natural language for the text options of the exercises. For example, this mutation operator applied is going to be translated into change, for example, an OR gate to an AND gate. If we follow the same order of the mutation operator applied, and in the reverse order if we need to undo the applied mutation operator. So if we need to go backward, as in some exercises it is needed. And after that, we define this can be done by the professor of the course. She enters the tool and she can configure the different exercises, select which kind of exercises is going to use, and also input the alternative textual representation of the models. In this case, the logic circuits can be expressed by their Boolean expression. And for each model taken into account, we, for each kind of exercise, we describe the statement of the exercise. For example, in this case, does this logic circuit correspond to the below Boolean expression? The Boolean expression is automatically generated by this mechanism. And well, we complete the whole configuration. And after that, we are ready to generate the exercises. Currently, we support the Moodle platform, Android, iOS, and the web. So, well, first we need to specify the preference page, the different options to generate the mutants for the Wodel preferences, and also for the Wodel-Edu tool, we need to specify which target platform, also which renderer we are going to use to represent graphically the models. And well, this is ready to be the generation is ready to be executed. And after the mutants generation that have been done there, then the tool generates the resources for the exercises. As we see, these are the graphical representation of the models, also of the mutants. And this is the XML for the question bank of the Moodle course. And well, now we can proceed with the part corresponding to the students. We have generated the exercises. Now the students can complete these exercises. This exercise corresponds to the text drag and drop kind of exercises. So, well, this is in the Moodle platform. And well, it consists in completing the gaps. Well, this other kind of exercise is the missing words kind. Also, we have drop-down lists for each blank and with the corresponding options. These text options are generated by the model text and mutatext DSLs. And well, here we need to match the left part with the right part, that is a Boolean expression with the mutation operator applied. In this case, the input AND gate is this one, and the output OR gate is this one. Okay, well, we used this notation because, well, we needed to achieve a simplified way to name the elements, maybe with complex or more complex circuits, an ID or a number for each gate should be better. But in this case, we were only using like at most three levels in the logic circuit. Well, we have here the alternative response with a Boolean expression in each option, and here we have like to select from the text options which ones fix the presented diagram. Okay. Well, this is another example. This last page is another example of the alternative response kind. Well, we included also a code generator for the Android platform. This was done by Andrés Rico Fernandez, who was a degree student working in his final bachelor project, in his bachelor thesis. And well, as you can see here, we have the graphical representation with these colors for the mutation operators applied. And well, this is the same, like the same format or the same kinds of exercises in the Android platform. Maybe here is too tiny, but in the mobile phone, maybe it appears clearer. Well, I think I can follow. And also we generated exercises for the iOS platform that was done by Jaime Velázquez Pazos, another degree student. In this case, this example is generating exercises for the domain of deterministic finite automata. It has also these configurations, these configuration files for the domain, and well, just the same. The only thing that changes is the code generator. The target platform is in this case the iOS operating system. So finally, we generate exercises also for the web. So, well, we have another example here. It's it's also applied to the deterministic finite automata. In this case, we are using a different graphical tool to represent the models. It's the GraphBeats tool, as you may know. And well, they are automatically corrected as automatically graded, as you can see. Okay, and finally, sorry. And finally, we can provide the grades to the student. This is in the case of the Moodle platform, the exercises that the student has completed before are corrected automatically. The solutions are included in the question bank provided to the Moodle course. Okay, so just to conclude, we have presented today that Wodel-Edu automates the generation and evaluation of online exercises by using a model-based approach. It is domain independent and supports automated grading, enables large-scale generation of 7 kinds of exercises, and automates the generation of sim models and alternative textual representations. For the future work, we plan to extend Wodel-Edu to support gamification and other types of exercises, like supporting interactivity via direct diagram manipulation and so on. And we also plan to use Wodel-Edu in other domains, such as software design or electric circuits, and so on. Okay, well, the presentation has finished. Many thanks for your attention. Now we have time to answer any doubt and also to use the tool and take a look at its execution live. Many thanks.